Students, these are some properties of matrix addition and scalar multiplication. That is multiplication of a matrix by a scalar. By a scalar means a number. Suppose capital A, B, C are three matrices of same size or same order, so that they can be added, subtracted like this. And lambda and mu are two scalars. Scalars means numbers. Then first property is A plus B equal to B plus A. A plus B equal to B plus A, that is matrix addition is commutative. It is a commutative operation because elements of matrices we are considering are numbers or functions, and addition of numbers, real number or complex number, are commutative. So this A plus B becomes B plus A, means matrix addition is commutative. Then number 2 is matrix addition is associative. First two added or last two added first. Bracket changes. You can associate A and B first, or you can associate B and C first. Answer will be same. This is called associative property. Addition of real numbers or complex numbers or addition of functions are associative. That's why matrix addition is also associative. Then third property is A plus null matrix equal to A equal to null matrix plus A. Null matrix means zero matrix. All its elements are zeros. So if a null matrix is added with a matrix, then its elements will not change. It will remain same. But this capital O must be null matrix of same order or same size as that of A. Then only you can add. This is called additive identity, because adding capital O with A from the left or from the right, the value of A remains same. That's why it is called additive identity. Then minus A plus A, that is negative of A. Minus A plus A equal to capital O. Capital O means null matrix equal to A plus minus A. If you add negative of a matrix with the matrix itself, then you get null matrix. Every element will become 0. So that's why this minus A is called additive inverse. Adding with these two, we get additive identity. Then fifth property is lambda into A plus minus B is lambda A plus minus lambda B. That is lambda distributes. Scalar multiplication is distributive. Lambda is distributive with respect to addition or subtraction. Then lambda plus minus mu is into A equal to lambda A plus minus mu. Means here also capital A distributes from the right. True. Then seventh property is 0 into capital A equal to capital O. See, this is 0, integer 0, real number 0. And when every element of a matrix capital A is multiplied by 0, all elements will become 0, and that means it is the null matrix. That's why it is capital O. Of course, its size will be same as that of A. That is, order of A and O will be same. Then number 8 property is 1 into capital A equal to A. Very obvious. If you multiply every element of a matrix capital A, then by 1, then the elements will remain same. So 1 into A is capital A. Number 9, A plus A. A plus A shall be denoted by twice A, because every element of A will be added with the elements of A. That means elements of A will get doubled. So twice A. Similarly, twice A plus A will give you thrice A. Thrice A plus A will give you 4A, etc. So these are the properties of matrix addition and multiplication of a matrix by a scalar. Next we shall do matrix multiplication. Now let us see multiplication of matrices. Two matrices, say capital A and B, are said to be conformable for the product AB. They can be multiplied in the order A into B, denoted by A into B, if the number of columns of the first matrix prefactor capital A is equal to the number of rows of the post factor capital B, that is second factor. Only then A and B can be multiplied in the order A into B, not B into A into B. So let us see. Suppose capital A is a M by N matrix, Aij, M by N matrix, M rows, N columns, and capital B equal to B JK N cross P, means it is a N by P matrix. We have taken number of columns of A as N, number of rows of B as N, same. They can be multiplied. In this case, they are said to be conformable for the product AB, means AB can be obtained, conformable for the product AB, A into B in this order. Now, how to find the product? In this case, AB is equal to CIK. first bracket, then M cross P. Cik means element in the ith row and kth column of the product AB, and here M cross P means this is a matrix of order M cross P. It is a M by P matrix. First one is M cross N, second one is N cross P. Then this N as if transitive property, NP, it goes to N to P. So M cross P matrix. This AB is, and we read it M by P matrix. And it is given by Cik. Now question will arise, what is Cik? How to calculate Cik? Means general element of the product AB, ith element. This Cik is obtained by multiplying corresponding elements of ith row of capital A, first matrix, with kth column of post factor, second matrix B, and then adding correspondingly. See, it is like right angle. First element AI1 into first element B1k plus second element AI2 into second element B2k plus dot 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 dot. Last element AIN, here last element BNK. So this is the ith element, and in short we can write sigma Aij Bjk j from 1 to n. So this is definition of product. Now example will make it clear. Let us see this example. Suppose capital A equal to ABC XYZ, 2 rows 3 columns, 2 by 3 matrix. B equal to DU EV FW, that is DEF here, UVW there. It is a 3 by 2 matrix, means 3 rows and 2 columns. So see, number of columns of A 3, number of rows of B 3. So conformable for multiplication for the product. And incidentally, in this case, this A and B are also conformable for the product BA. If you take B first, then number of columns of B is 2 and here number of rows of A is 2. So BA can also be obtained. That is, BA is defined. You can say that AB and BA both are defined. But AB is a 2 by 2 matrix. 2, 3, 3, 2. So 2 goes to 2 like that. Transitive property, 2 by 2 matrix. And if you start with this 3, 2, 2, 3, it will be 3, 3. 3 by 3. See, BA is a 3 by 3 matrix. Now, how to find AB? Rule is like right angle. In first matrix, we move horizontally along the rows, and in second matrix, we move vertically downwards along the column. First into first, A into D, see AD written, plus second element B, here second element D, B into E, see B is written, plus third element C, here third element F, C into F, CF written. So first row, first column, we have multiplied, we have got first element of the first row. Then we go to the second column because there is another column remains. So again, this row now we shall multiply with second column. First element A, second, here first element U. So AU, see AU, plus second element B, here second element B, see BB, plus third element C, here third element W, CW. So there is no other column, so first row of the product obtained. Same action now we shall take with second row. With second row, if we multiply, we shall get the second row. If there is third row, we shall get third row, but here only 2 rows. So same action we take with second row. This time, this XYZ will be multiplied with this DEF. X into D plus Y into E plus Z into F. See? Then same action with this second row with second column. X into U plus Y into V plus Z into W. See, X, U, Y, V, Z, W. So horizontally and vertically downwards. But corresponding elements are to be multiplied. First into first plus, second into second plus, third into third. If there are double minus sign or 1 minus 1 plus, you will see the plus minus sign also. So this is how we have found AB. AB is obtained and it is a 2 by 2 matrix obviously. Now let us calculate BA and see what happens to BA. How BA is a 3 by 3 matrix we shall see now. So let us write BA here. BA. B is DEF UVW and A is ABC XYZ. Now Let us multiply by same rule. Here this time, see, rectangle is if d into a, dA plus u into x, ux. First element we have got. First element we have got. Then with first row, let us finish all columns. First row, first column, first element. First row, second column, second element. First row, third column, third element. Like this it will move. So now again right angle if we bring here, it will be dB, first into first, second into second, plus uy. Then same action if we take with third column, it will be dc plus uz. Three elements we have got with first row, three elements, first column, second column, third column. Now let us start with second row. Same action, second row if we take e into a, ea, plus b into x, vx. Then with second row, second column. Another thing you can note, when we write second column, second row of the product, see EB, this B and Y, C and Z will remain same, only DU. Here first row was DU and second row is EB. Now it will replace by EB. So I can write without looking into there, here looking, I can write the answers. It will be EB plus VY, EC plus VZ. Because this C and Z, this B and Y will remain same. Now same action I can do with FW, third row. With third row I shall get the third row of the product. So it will be, third row is F and W. See, without looking there also you can write the answer. FA and WX, because FW. EB replaced by FW. Here FB WY, EB VY, now it is FB WY. Here will be FC WZ. You can check again, F into C plus W into Z, or directly looking here you can write the answers. So this is 3 by 3 matrix. See, AB is a 2 by 2 matrix and BA is a 3 by 3 matrix. Sizes are not same. So in this special case, AB not equal to BA. AB not equal to BA. But if A and B are square matrices, of course AB and BA will be of same size and yet they may not be equal. We shall see later, they may not be equal. So this is matrix multiplication, how to multiply. We have learnt, and in the PDF you will get more examples. Let us see one practical example. Say A equal to this matrix 1, 2, minus 4, 5, B equal to 0, minus 1, 2, 3. Both are square matrices of order 2. Now, how, in this case, AB and BA both can be octet. Let us see what is AB. So, 1 into 0 plus 2 into 2. See, first row, first column. First into first plus second into second. Then we go to second column here, first or second column. It will be 1 into minus 1 plus 2 into 3. See, 1 into minus 1, second element 2, here second element 3, 2 into 3. Same thing we shall take, same action we shall take with second row. If we take with second row, the elements will be minus 4 into 0. Minus 4 into 0 plus 5 into 2. Second row, first column. Now, then second row, second column. Minus 4 into minus 1 plus 5 into 3. Second into second. So, what is the answer? This is 1 plus 4, sorry, 0 plus 4, minus 1 plus 6, and 0 plus 10, 4 plus 15. In practical calculation, this line, this second line, we may omit. Directly from this we can write this answer, and it will be ultimately 4, 5, 10, 19. See, we have calculated AB 2 by 2. A is 2 by 2 matrix, B is 2 by 2 matrix, so AB is also 2 by 2. No change in the sign. 2 cross 2, then 2 cross 2. So first and last also 2 cross 2. Now if we want to find BA, see, BA will not be equal to AB. Side same, but values will not be same. You can check. It is 0 into 1, 0, plus minus 1 into minus 4. This time directly we are writing minus 1 into minus 4 will be 4. Then first row, second column. First row, first column we have completed. Then let us go to first row, second column. First row, second column will be 0 into 2, 0, plus minus 1 into 5 is minus 5. So directly we write minus 5. Similarly, second row, 2 into 1, 2. 3 into minus 4, minus 12. 2 into 2, 4. 3 into 5, 15. See the answer. 4 minus 5 minus 10, 19. 4, 5, 10, 19. Here 4 minus 5 minus 10, 19. Say AB not equal to BA. Sizes are same, order same, but AB not equal to B. So this is how we multiply matrices. Another example, let us see. This is a 2 by 2 matrix. 2 by 2. This is 2 by 2 matrix. This is 2 by 3 matrix. So final answer will be 2 by 3. Answer will be 2 by 3 matrix product. So answer will be first row, first column. If we draw like this, answers will be 1 into 2, 2. 2 into 5, 10. So 2 plus 10. Then 1 into 3, second column if you go, 3. 2 into minus 6, minus 12. Then 1 into 4, 4, plus 2 into 0, 0. So first row, second column, first row, third column finished. Then second row, minus 4 into 2, minus 8, plus 25, 5 into 5. Then minus 4 into 3, minus 12, minus 30, 5 into minus 6. Then second row, last column, third column, minus 4 into 4, 16, minus 16, plus 5 into 0. So this is 12 minus 9, 4, 17 minus 42 minus 16. This is 2 by 3 matrix, 2 rows, 3 columns. So we have calculated AB. Incidentally, what we see here, BA is undefined in this case because B is a 2 by 3 matrix and A is a 2 by 2 matrix. So see, number of columns of B is 3 and number of rows of A is 2. So 3 not equal to 2. Therefore BA cannot be obtained. So A and B are conformable for the product AB, but these matrices are not conformable for the product BA. So we have seen earlier AB, BA both can be found, but they are not equal. Here AB can be found, BA cannot be found. Sometimes BA can be found, AB cannot be found. This may happen. This is the property of matrix multiplication and main feature of matrix multiplication. And also sometimes if A and B are two square matrices, of course in that case AB may be equal to BA, only in special case AB will be equal to BA. We shall see later. Thank you. This is about matrix multiplication and some properties of matrix multiplication I shall write now. Now let us see properties of matrix multiplication. Properties of matrix multiplication. Suppose A, B, C are 3 matrices, but this time they should be of suitable orders, suitable sizes, so that product can be defined depending on the situation. In addition property we have written ABC are all of same size. Here ABC should be of suitable size so that the following operations are defined, means BC, AB, etc. to be defined. So first one is ABC equal to ABC, means bracket changed. Associative. First we will associate first, or second, third associate first, answer will be same. But this is not easy to prove. This is a result. Matrix multiplication is associative, like addition. Then number 2 is left distributive property. Left distributive property of multiplication over addition or subtraction. A into B plus minus C is AB plus minus AC, like our numbers 2. Then it is right distributive property. A plus minus BC is AC plus minus BC, like numbers, they are also true. Now here it is lambda. Lambda is a scalar. Lambda is a scalar, that is a number. It is lambda AB equal to lambda AB is equal to A into lambda B. Means scalar can be put anywhere. Either you associate with A or you associate with B, no matter. This is property of scalar. And number 5 is important. Suppose capital A is a m by n matrix, then Im into capital A unit matrix is equal to capital A equal to A into In. Means left side unit matrix is of order m, right side unit matrix is of order n if A is a m by n matrix. Both I are not same. They are both unit matrices, but their sizes are different. This is important. But if A is a square matrix, then of course left and right side I will be same. So in that case we do not write In, only I. IA equal to A equal to AI, means as if I is serving the purpose of 1 in real numbers. 1 into any number is that number, like that. Here is I into A equal to A into I. That's why this I is called identity matrix or multiplicative identity. Behaves like 1. This you can verify. You will get the verification in PDF also. I am not verifying here. Then number 6 is A into O equal to O, null matrix. A is a matrix, O is null matrix, but of course suitable size, means number of columns of A should be equal to number of rows of this O, and only then you can multiply, and this is null matrix. Similarly, O into A equal to O. Both this right side O and this left side O may not be same, because A may not be a square matrix. So O into A, here number of columns of O should be equal to number of rows of A. Answer is again null matrix. Every element is null, so sum product will be automatically 0, all zeros. Number 7 properties S square. S square, how you find? A into A. It is not that square of all the elements of A. Not like that. You have to multiply row and column like that, rectangle process. So S square. A cube will be S square into A or A into S square. Similarly, A to the power 4 will be A cube into A or A into A cube, like that. In general, you can calculate A to the power n for any positive integer. Then I square. I square is I into I equal to I. Because I into any matrix is that matrix. I into A is A, so I into I will be again I. B implies 1. I cube is also I. I to the power n is I in general. And last one is, this is not mod AB, this is determinant of product A and B is equal to determinant of A into determinant of B. So these are the properties of matrix multiplication, and examples you will get in PDF. Nicely I have explained also, and thank you for today.